Welcome to the 13th of 14 videos on the Arc Flash Truth No One Explains. My name is Joe Chacon. I'm the president of Podge LLC and Chacon Engineering. I'm a licensed professional engineer in multiple states and have been an electrical engineer for almost 30 years. Please like and subscribe as this helps us get this important information in front of more people. This video is going to address arc resistant gear. This is where we take a piece of gear into a high current lab, intentionally blow it up to a defined standard, and then give it a certification. IEEE controls the standard relating to this. It is called C37.20.7, and 2024 is the latest edition at the time of this recording. They define arc resistant as equipment designed to withstand the effects of an internal arcing fault as indicated by successfully meeting the test requirements of IEEE standard C37.20.7. It is quite difficult to make an enclosure fully arc resistant. So the standard provides two primary definitions and four sub-definitions they refer to as suffixes. The first primary definition is called type 1, meaning arc resistance at the freely accessible front of the equipment only. The second primary definition is called type 2, meaning arc resistance at the freely accessible exterior of the equipment only, meaning front, back, and sides. Keep in mind the caveat of freely accessible. Now, let's look at the four suffixes or the sub-definitions. The first one is suffix A. Honestly, I'm not sure why the standard has this suffix as it means almost nothing. Type 1A is the same as type 1 and type 2A is the same as type 2, minus one obscure caveat they have a little bit later in the standard. The second one is suffix B. This means that a low voltage control or instrumentation compartment is arc resistant with the doors open. Each door or cover will need to have this language on it that was tested. The third suffix is C. This means internal arcing faults are contained so that they do not propagate to adjacent compartments within the switchgear assembly. Assume you have multiple internal compartments like you'll see in an MCC or solar inverter, for example. Type C means that what happens in one compartment stays in that compartment and does not spread to another compartment. Type C arc resistance is similar to fire-rated apartment building. A fire might occur in one apartment, but the construction prevents it from spreading to adjacent compartments. It is not implied that the fire is safe, only that it's contained. So, I have many people want me to apply multiple IEEE 1584 arc flash labels to solar inverters and other equipment with multiple compartments. The argument that is often cited is, well, the internal rigidity of the inverter will prevent intercompartmental arcing propagation. I cannot do that unless the device carries this IEEE C37.20.7 rating that proves that it will. That's the proof that the required internal rigidity is actually there. Therefore, I always put the worst case incident energy on a lineup like a solar inverter when the C37.20.7 certificate is lacking. The final suffix is suffix D. Unlike type 1 and type 2, which assume generic accessibility, suffix D allows arc-resistant testing to match the actual installation. For example, when a switchgear lineup is installed against a wall, only the accessible faces are tested and rated. The big idea is restricted access. All right, table C.1 in the standard gives all the different types of type 1 and type 2 suffixes available for 9 different types of equipment. I'm not going to show you that as we can go down a long rabbit trail, but I do want you to know exactly where it is. Okay, I need to tell you the pass-fail criteria, which comes from section 6 of the standard. Let's go through all 5 criteria. Criterion 1, latch doors and covers do not open. I've done multiple arc-resistant tests, and this one is probably the one that usually fails the most. You wouldn't believe the amount of pressure that's exerted on a door. Criterion 2, Marginal fragmentation of the enclosure occurs during the time specified for the test. This standard tells you exactly what they mean by marginal fragmentation, and they literally define the number of grams of ejected small parts that are allowed. Criterion 3. Any opening in the area under assessment that results from direct contact with the arc is a failure. So, we line that entire surface with burn indicators that we're putting under test. Whichever side we're testing, we put burn indicators up and down that. So, here's criterion 4. Gases and flames escaping the equipment do not ignite the burn indicators outside the enclosure. Finally, criterion 5. All the grounding connections remain effective. The testing will always accompany a report, and then you're able to apply the nameplate citing compliance. IEEE 1584 quantifies arc flash hazard severity, while IEEE C37.20.7 evaluates how equipment contains an internal arc. Arc resistance performance can influence exposure assumptions, but the standards address different aspects of risk, and neither standard nullifies the other. We'd love to help you with a test program to evaluate your gear for arc resistance and offer consulting services while designing that gear. The next video is going to summarize everything we've examined over the last several videos.